Okay, friends, we're continuing our conversation from yesterday about electron configurations, right? And we made this incredibly complex chart yesterday. It's not that bad, though, right? It just looks awfully busy. We talked that each energy level, which are the rings, have a certain number of electrons. Number 1 has 2, number 2 has 8, number 3 has 18, numbers 4 through 7 have 32. And each of those energy levels has sublevels, right? The number of sublevels depends upon how many electrons it can hold, right? That the first energy level, since it only holds 2 electrons, only needs an S sublevel, because that holds 2, right? So therefore, 1s is all you get. The 1 meaning the energy level, S meaning the sublevel. Cool? For the second energy level, because now we need 8 total it'll hold, so we need an S and a P. Some people drink frappuccinos, right? SPDF. So we have a 2S and a 2P. For energy level 3, SPDF, because now we're up to 18, right? 2, 6, 10 as far as sublevels go. And last but not least, in the 4th as well as 5th and 6th and 7th energy levels, we have SPDF. And that F sublevel holds 14. You all seem to be pretty comfortable with that yesterday, which again, I appreciate you staying with me. So we end up kind of with a list of sublevels, right? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, right? And we can keep going to 5s and 6s, etc. We're cool? And remember, the whole point of this is so that we can know where the electrons are, right? Because those are the things that interact, those valence electrons. We want to know where they are, which will help us know how they will react. We're cool? So when you see a list like this, when we try to make an electron configuration like we did over here on the right side yesterday, when we make that, you probably think that they look something like this. If I put them in colored, you would think that 1s would fill up first, right? Then 2s, then 2p, then 3s, then 3p, then 3d, then 4s, then 4p, and etc., right? In the same order that we wrote them on our diagram, right? The same order we had them on this diagram. You would think logically that they would look in that same way, kind of like a ladder, right? And it's going to fill up the bottom ones first and continue to move up. What we find is that's not actually how it works. Okay? And for that, we'll have to pause because the phone's ringing. Sorry, we're back here. So in actuality, they don't actually work that way. What's the crazy thing is, it looks more like this. If you took your fingers, instead of them being like this, right, they're actually interspersed together. The order goes something like this. You ready to memorize this? 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4. How in the world are you supposed to remember this? Okay? 2 easy choices. Now, I'll show you. There's something called an off-bow diagram. That if you put, this is in the reading yesterday you did, right? If you line them up like this, you could just make these little squiggly lines to go through. Okay. So either you memorize it outright, right? You learn to draw one of these off-bow diagrams, or what if you, okay, the internet, but what if you simply just use this lovely periodic table? What if I told you the shape of the table helps you know what order they fill up in? Because of this. Here's my lovely periodic table. I can break it into 4 sections. That these guys, groups 1 and 2, These are the S. We call it the S block. These guys over here, groups 13 to 18, are the P. Groups 3 to 12 are the Ds. And what do you think the Fs are? What are they called? Do you remember? Oh, that's a real name for the top row is the actinides, the bottom row are the lanthanides. The whole thing is called the inner transitions. That would be your F block. Okay, you with me? That the periodic table, you can actually break it into these 4 sub-level pieces. And then all you have to do, friends, is simply follow the atomic number. And if you move along the periodic table and you know what block you're in, you can assign it a sub-level. Let's demonstrate. Okay? So let's pick... Lithium's way too easy. But we can do it. How about lithium? Lithium is number 3, atomic number. Okay? We always start up in the top left at hydrogen, right? And you notice, by the way, that hydrogen's over here and helium's over in this group 18, right? So for this and for this only, you have to think of hydrogen and helium as being over here on the left. You have to basically move helium over there. Okay? Now, why don't we just put helium over group 2 then? Anybody have an answer for that? Yes? Okay, so it has 2 valence electrons. All of the group 18 have 8 of them. So actually, it would fit better over in group 2 for valence electrons wise. Yes, ma'am? Its outer ring is full. Okay, so how does that affect it then? Because you're right. It's stable. It's a noble gas. It won't react, right? Yeah. So it has properties that are much more like these guys than it does group 2. Does that make sense? So we put it over there on the PT, over in group 18, but for electron configurations, you have to think of it as being over here in period, or in group 2. Does that make sense? Sir? Mm-hmm. Well, remember, if we go back to this diagram, this first level, how many electrons can it hold? 2. So when that level is full, with 2, it's happy. It's just like all the other elements needing 8. Oh, in this case, it only needs 2. It's one of the 2 exceptions that don't fit that octet rule. Helium and hydrogen only need 2 to be happy. Everything else needs 8. Okay, it's a good point. All right, so back to our diagram, lithium. Okay, so what block did we say this periods 1 and 2 are? Or groups 1 and 2? This is the S block. And we use the number of the periods that tell us what energy level. Remember I said yesterday, energy levels are periods, right? So therefore, lithium begins in 1s. And how many electrons do we put in 1s? 2. It'll hold a maximum of 2, right? And we have 3 electrons to place, so we'll put 2 of them in the 1s sublevel. Can I put all 3 of them there? No, why? It only holds 2 in the 1s, in any s sublevel. We cool? So where is the next one going to go? Remember, the next level would be what? So if I'm following atomic number, 1, 2, I drop down here. This is period 2, right? So energy level 2. What block is this? The S. So 2s, how many electrons are going to be there? Just 1. So the electron configuration for lithium is 1s2, 2s1. These numbers on top should always add up to that number. That's a way you can check to make sure, because every electron has to be assigned an energy level. Maybe, possibly, potentially, theoretically. Okay, let's try another one. I'm going to erase this. Let's pick another one that's a little bit longer here. Okay? Let's pick titanium. Someone want to sing the song for us? Titanium. 22? It's bulletproof, right?
I love this.
Good? Okay, let's start. Again, from the very top left, from hydrogen we begin. So hydrogen starts with 1s. How many are going to fill up 1s? 2. So that takes us over to helium, right? Now we drop down. What's the next one? By the way, I should really give you these back. Just don't write on these. Again, you can write on your textbook, that's fine. If you want these PTs, you're welcome. So you can see, you can follow along. It works much better. And here I took them all away from you. Okay, so we're over to helium now. Helium filled up that 1s2, right? So what comes next? We're at lithium, right? And that's 2s, right? 2s. And how many can that 2s hold? 2. Again, we got 22 electrons to get through, right? So we've got 4 so far. Okay, so we got a lot more to go. What else? What comes next? So 2s is here, beryllium. Again, follow the atomic number. This was 4. Now we're to 5. Now we're over into 2p. And you say, wait. Where'd the 1p go, Mr. Hess? Remember, we don't have a 1p, right? The first energy level only holds 2. It doesn't need a p. Okay? Sir? Hydrogen was that very first piece we did. 1s. So if you wanted the electrical configuration for hydrogen, it'd be 1s1. Heliums would be 1s2. Lithiums would be 1s2, 2s1. All right, stay with me. You'll get it as we're going. So we're in 2p now, right? 2p is here, boron. We're going to fill up all 6 of borons of the 2p level, right? So that'll be 2p6. Because, right, it holds 6. How I did that, I'm right here now. What element am I at currently? I'm at neon. Because look, neon is the end of the 2p. Remember, this is the p block. So I'm here in 2p. We filled up 2p, so it has 6. But I haven't got to titanium yet, right? Okay, so now I'm going to go into 3s. The 3s can hold how many? 2, good. Now I'm here at magnesium, number 12. Now where do I go next? 3p over to aluminum. So 3p, we're going to fill up all of 3p. So 3p6. Okay? Now I'm over here at argon. We good so far? I think many of you are with me at least. We'll do more, don't worry. Okay, now where do I go? Oh, no. I'm here at argon, which is 18. It drops down to number 19. What space is that? That's 4s. 4s, we're going to fill up both of those, right? And now I'm here at calcium, number 20, right? If you count up all those numbers, it's 20. That's the superscript numbers. So now from calcium over to scandium, what level am I at now? I'm at the D, but I'm not in 4D, because remember, the first D sublevel that happens is 3D, right? So it's going to be 3D. How many am I putting in the Ds? Just 2, because titanium's right here, right? Is number 22. There's only 2 electrons that will go into that sublevel. If I add 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 2, it equals 22. So the D block, and I promise to get your question. The D, you have to take away 1, oops, not from the period number. And F block, you actually subtract 2. Man, I did it again. From the period number. So this is not the 6F, even though it's in period 6, it's actually the 4F. This is not the 4D, even though it's in period 4, It's 3D. S and P, they stay the period numbers. That never changes. Maybe. Some of you good head nods. Others of you are like, Mr. Hess, you're talking Greek. Try one. Okay, I'm going to give you one. I want you to try it. Let's try antimony. Antimony is number 51. Antimony is SB. Number 51. You give it a try. We're running out of time, so as you're going, I'm going to put them up here because we've only got about 3 minutes left. Give it a shot. Yeah, this is not to turn in. This is just as notes. Give it a shot. Five P? 3. Okay. How do I know it's 5P3? If I'm looking at the P block, antimony, number 51, is 3 places in. Right? Indium would be 5P1, tin would be 5P2, antimony is 5P3. Whew. Hopefully, you will see that this should not be incredibly difficult. Where I'd love for you to go, and forgive me, I think this is the next slide, but I just want to make sure I don't give you the wrong numbers in the 30 seconds before the bell rings, if that. See, told you. Number 21. We're on page 160. I want you to do number 21, which is asking you to do the electron configurations for about 6 elements. And actually, we just did antimony, one of them, so that's cool. All right? Again, this is in 5.3. Adios, friends.